Okay, let's continue with a couple more examples of working with expressions, multiplying and dividing expressions with exponents. So in this case, I have a little bit of extra mess just in the fact that I do have more variables in the mix. And it's our first division that we've looked at, but I don't think it'll give us too much trouble. Again, the nice thing with exponent rules mixed with multiplication and division is they're all sort of in the same tier, so you have a lot of flexibility. So I'm going to stick with my usual scheme of dealing with negative exponents first. Truthfully, what happens is that z to the negative 3 does end up just getting pushed to the top, but as soon as you throw addition and subtraction in the mix, that can get really confusing. So I want to be careful about that. I'm going to write that as 1 over z cubed. That I know for sure, no question ever. Z to the negative 3 is always the same as 1 over z cubed. Okay, so finishing cleaning up the bottom, I'm going to say if we put these over 1, I can write that as a single fraction. So I'm supposed to be multiplying 3 things together. I'm going to have an 8z to the 4th, I'm sorry, 8x to the 4th over z to the 3rd. So this did create a complex fraction, fractions and fractions. But really, again, you want to not get lost in the mess. What we're saying here is we want to divide negative 4 z to the 5th x by 8x to the 4th over z cubed. And always dividing is the same as multiplying by a fraction, 5th x. Multiplying by a reciprocal. So we're going to flip z cubed over 8x to the 4th. And then we're going to multiply those together. So I'm going to say I have negative 4 z to the 6th times z cubed is going to give me 9 z's total. I have 6 factors of z and then 3 more, so 9 factors of z. So we're counting factors. And then on the bottom I have 8x to the 4th. Okay, so now finally negative exponents are dealt with, and I'd like to just do a little bit of canceling. When I look at the coefficients, that's a little bit of canceling that I can do. 4 goes into 8 twice, so that leaves a 1 on the top and a 2 on the bottom. I can also cancel out the single x. There's no z's on the bottom, so I'm stuck with those, but if I cancel out a single x, I'm going to be left with x cubed on the bottom and 1 on the top. So negative 1 times z to the 9th times 1 is negative z to the 9th on top, and 2 times x to the 3rd on the bottom. Okay, let's go ahead and do number 4. So really same idea, but the fractional exponents I know freak people out a little bit. So remember the rules are exactly the same with fractional exponents. So I'm going to go about my business and I'm going to start trying to rewrite things without the negative exponents. And it might get a little ugly here, and it's not your only choice. So always feel free to break away. This is an example of when I actually probably wouldn't, left to my own devices, deal with all the negative exponents the way I have been. In particular, right here, you could multiply exponents, negative 1/8 times negative 2, and you get a positive. But I'm going to go about it the same way I have been so that I'm not giving you different rules for different problems. So k to the negative 1/2 is the same as 1 over k to the positive 1/2. K to the negative 1/8 is the same as 1 over k to the positive 1/8. And then I'll deal with this one in a second step. K to the 5th. Okay, so I dealt with 2 of them, and you don't have to, the order doesn't really matter on that 1 over k to the 1/2, 1 over k to the 1/8, and the negative second power. You can do those in either order, stumbling through my speaking there. Okay, so if I try and keep going with this method, here, let's go ahead and multiply across to make this a little easier. I get 12 over k to the 1/2, and then I have 1 over 1 over k to the 1/8 squared. Okay, so I'm not saying you have to do it this way. It does get a little messy. What I am saying is that it is always okay to say something is raised to a negative power. I put it underneath 1 and make the power positive. Always okay to do that. So if in doubt, this is always safe. People start to get confused about when they can just push it to the top or the bottom of another fraction. So you can always go back to this. Okay, so let's keep working on it. 12 over k to the 1/2. I'm just going to leave alone for a little bit longer. I'm going to go ahead and get rid of the parentheses. I have 1 over k to the 8th squared, which is the same, two ways to think about it, as 1 over k to the 8th times itself. K to the 1/8 times itself. You can also, so that's one way to look at it, you can also use your exponent rule that says that's the same as 1 squared over k to the 1/8 squared. Notice those mean the same thing, so two slightly different ways to think about it. Either split the exponent top and bottom or multiply that thing by itself. Whichever way you're doing it, we still have the big 1 on the top, 1 in the top of the little fraction, and k to the 1/8 squared. Remember, for the bottom one, you'd multiply 1/8 by 2, so you'd get k to the 1/4. That 4 is not showing up. There we go. Over 6k to the 5th. Okay, so now finally, looking at this big fraction, I can go back to what I was talking about in the last one, fractions and fractions. We have a lot of those, but let's just deal with one at a time. Instead of writing that as 1 over k to the 1/4, I can think about it as 1 times k to the 1/4 over 1. Multiply by the reciprocal, and that works out really nicely. Basically, the reciprocal of the reciprocal is just the number that you started with. I'm going to go ahead and write that over 1 since we're multiplying fractions. This is a 4. And I still have the 6k to the 5th in the bottom. So I'm just going to point out while I'm talking about this, if we take the reciprocal of k to the 1/4 and then take the reciprocal of that and get back to k to the 1/4, that means reciprocal is its own inverse operation. If we reciprocal twice, we get back where we started. Okay, so I'm going to go straight across on the top. That's a 12k to the 1/4 over k to the 1/2 all over 6k to the 5th. Okay, so in the top of that fraction, I have k to the 1/4. On the bottom, I have k to the 1/2. So that's the same as k to the Did I lose you? Nope, I didn't lose you. I don't know what that looked like to you, but I don't want to lose my whole video, so I'm going to keep going. So it's the same as k to the 1/4 minus 1/2. What do I want to do? 1/2 is the same as 2/4, so 1/4 minus 2/4 is negative 1/4 over 6k to the 5th. Okay, and I made a new mess for myself, just a little bit of 1 though, so I'm going to say, okay, that's 12 times 1 over k to the negative 1, or 1 over k to the 1/4, so it's the same as 12 over k to the 1/4. And that's divided by 6k to the 5th. And I'm going to go ahead and think about that as over 1, because my next step is going to be multiply by the reciprocal. 12 over k to the 1/4 times 1 over 6k to the 5th. We can cancel a 6 out of that, so we get 2 on the top. On the bottom, we have k to the 1/4 times k to the 5, which should be k to the 1/4 plus 5. 1/4 plus 5. And to make that denominator match up, we're going to have to multiply top and bottom by 4. So we're going to have k to the 21 over 4. Hopefully that looks like like a 1. Okay, so kind of messy, and as you get comfortable, it really is okay for you to combine some of those steps. It's also okay for you to take a different order. I am making zero claims that the way I just did that was the easiest, but it is an option. So now that I've shown you how to do it kind of the safe way, where we always deal with the exponents in the same way, let me just snag a different color. What do I have here? But like a pink. And show you another option. So first and foremost, you need something that you know works before you start monkeying around. Another way you could approach this, though, is we could start by clearing those parentheses on the top. If we take k to the -1/8 and raise that to the -2, we should multiply powers. So -1/8 times -2 becomes +1/4. If we then use the rule that says on the top you have k to the -1/2 times k to the 1/4, and you should add exponents, that's k to the -1/2 plus 1/4, which is the same thing as -2/4 plus 1/4. That should be familiar math. So this is k to the -1/4. -2/4 plus 1/4 is -1/4. Over 6k to the 5th. Okay, and then we can cancel. So I have 2k to the -1/4 over k to the 5th. And then we can use the rule that says k to the -1/4 over k to the 5th is the same as k to the -1/4 minus 5. Which remember 5 is the same as 20 over 4. So we have 2k to the -21 over, I wrote that wrong, 4, which is the same as 2 over k to the 21 over 4. So I think it looks a little better, right? That's a little bit shorter than the other way that I did it. But again, it doesn't matter if you get in a little bit of a tangle and you do it kind of a long way. I am not upset about it at all. I hope you're not upset about it at all. If you're doing correct steps, I don't care if you do it in a way that takes more steps. So you have lots of options. Pick one and don't be worried if you think there might be one that's a little faster. We hope to get more efficient over time, but we aren't going for perfect efficiency right off the bat with these things. We're just going for correct mathematical steps. So don't feel like you should know the exact, perfect, simplest, most beautiful way on your first try. Thanks for watching.